Now we discuss the expectation value of an operator. Suppose if A is an operator, the expectation value of the operator is defined as the integral over psi star A psi dx divided by psi star psi dx. Suppose if psi is a normalized wave function, then integral over psi star psi dx is equal to 1. Therefore, the expectation value is only the numerical part, integral over psi star A psi dx. If you take psi is a normalized wave function. Now, for an operator, this is a position operator x, that may be replaced by the x, the position coordinate. The operator px operator, the x component of the momentum operator, is replaced by minus ih cross d by dx. This is the operator, differential operator for the momentum. Px square operator is minus h cross square d square by dx square, and the energy operator may be expressed in terms of ih cross d by dt. Now, let us evaluate the expectation value of the position operator x, that is integral over psi star. So instead of a operator, you substitute x psi dx, psi star x psi dx. If you want to evaluate the expectation value of x square, then integral over psi star x square psi dx. Expectation value of momentum operator, x component of the momentum operator is minus, just substitute here. So this operator is substituted here. So we take minus h cross constant term can be taken outside from the integral. So minus h cross integral psi star partial d by dx of psi dx. Similarly, px square, the expectation value of px square is equal to minus h cross square psi star d square psi by dx square into dx. Now, using this definition, now let us calculate the expectation value of R for the ground state of electron in the hydrogen atom. Now, for hydrogen atom, the ground state this is a ground state of electron in the hydrogen atom. Ground state wave function is psi 1s is equal to square root of pi a naught q e power minus r by a naught is the Bohr radius. So this is a three-dimensional problem. So for a three-dimensional problem, the expectation value of R is equal to integral psi star R psi. Here you have to write down the volume element. Here, if it is a one dimension, you can write down this is dx. For a three dimension, you have to write down the volume element d tau. Now, the expectation value of R is equal to you have to write down the volume element. So psi star R psi, the volume element is R square dr sin theta d theta d phi. So this is a volume integral over there is a triple integral. One integral over the R radial part is 0 to infinity, another over theta part is 0 to pi, another over 0 to 2 pi. So this expectation value of R is defined as psi star here, because since it's a real function, so this is the same value of same value 1 by square root of pi a naught q power minus r by a naught, and here you have to write down r, then again psi. So here 1 by this into e power e power minus r by n. Again, so this is a psi star r psi into the volume element r square dr sin theta d theta d phi. Then the constant term can be taken outside from this integral, and this now let us evaluate the integral over the angular part. Integral over d phi is 2 pi, integral over sin theta d theta is 2. So if you evaluate the angular part, sine integral over sine theta d theta d phi is 4 pi. So that can be a constant that can be taken outside from this integral. So the rest of the value is integral over 0 to infinity e power minus, once if you combine these two, it becomes e power minus 2r by n r, and this is r square, then r is here, so this becomes r cube dr. So this is a integral that we have to evaluate. But there is a standard integral. If you can use the standard integral if you know. So some of the standard integral must you have to remember, so that you can do the calculation quicker. So 0 to infinity e power minus ax x power n dx is equal to n power n factorial divided by a power n plus 1, which is a gamma function, gamma of n plus 1. So you take this standard integral, definite integral. Now here the power n is equal to 3. So you have to calculate this. So this is the constant is 4 by n r cube. The integral value, since this if you compare these two, n must be 3, so this must be 3 factorial, and the coefficient is 2 by n r is coefficient, n power 1 is 4. So you substitute here and you simplify this expression, you will have 3 by 2 n r. So the expectation value of r is 3 by 2 n r. If a particle is in the ground state of the electron. Similarly, you can calculate the expectation value of 1 by r. 1 by r, we are doing the same problem, but instead of putting r here, you have to put 1 by r. So we have put 1 by r here. And the angular part we have, which is 4 pi, this you can take it outside, and this can be evaluated simply. So again using, so this integral reduces to 4 by n r cube, 0 to infinity, u power plus 2r by n r dr. Now again using this standard integral, or you can evaluate directly also. Then this is the value, and you simplify that expression, it becomes 1 by n r. So the expectation value of 1 by r is equal to 1 by n r if the particle is in the ground state. Similarly, you can evaluate the expectation value of r square. You can take this homework and you can do it very easily by using the same method. You can evaluate. You can find that this value is equal to 3 n r square, and the expectation value of 1 by r square is equal to 2 by n r square. So these are the 4 terms, expectation value, and mostly in the examinations, you may be asked to find expectation value of r, 1 by r, expectation value of r square, expectation value of 1 by r square. So then now so we have to just highlight that problem. Now let us take an example for using a harmonic oscillator, linear harmonic oscillator. Now let us find the expectation value of x if the particle is in the ground state of a linear harmonic oscillator. For a linear harmonic oscillator, the ground state wave function is psi is equal to a e power minus half alpha square x square. A is a normalization constant, and this a, the normalization constant is not given. That can be also determined by using normalization method, and that normalization constant is found to be alpha square by pi whole power 1 by 4. So the normalized wave function of the higher particle which is in the ground state of linear harmonic oscillator is psi is equal to alpha square by pi whole power 1 by 4 e power minus 1 by 2 alpha square x square. This is the ground state wave function of the linear harmonic oscillator. Now you are expected to find the expectation value of x. So by the definition, integral over psi star x psi dx, you substitute for psi, since it is a real function, psi star is the same value, so psi star x psi becomes, and you take this constant term outside from the integral alpha square by pi whole power half, integral from minus infinity to plus infinity x e power minus alpha square x square dx. Now what is the value? Now this value x e power minus alpha square x square, this is a odd function, and the integral is from minus infinity to plus infinity. So since it is an odd function and the integral is from minus infinity to plus infinity, so this integral value is 0. Therefore, the expectation value of x is equal to 0. Now, suppose if in the problem, if psi is given like this, alpha square by pi whole power by 4 e power minus half alpha square x minus x naught square, because this is a Gaussian function, and this is centered around origin. Now this is a Gaussian function which is centered around x naught, because the x minus x naught whole square. So this is again a Gaussian function, but the origin is shifted to x naught. Now if it is so, then you put x minus x naught is equal to a new variable called y, and dx is equal to dy. You substitute, you replace x by the new variable, so it becomes y plus x naught e power minus alpha square y square dx. So this can be split into two integrals, one y e power minus alpha square x square dy, the other part is x naught e power minus alpha square y square dy. Again this is a odd function, y e power minus alpha square y square is an odd function, and this limit of the integrations are from minus infinity to plus infinity, so this will vanish, so this will give a 0 value, and the non-vanishing value is this one. So x naught is a constant that can be taken outside, and the minus infinity to plus infinity e power minus alpha square y square dy. This is also a standard integral. The value is square root of pi divided by the square coefficient alpha square. So square root of pi by alpha square is this value. Now you simplify this expression, you will get x naught. So the expectation value of x is equal to x naught if it is centered around x naught. Otherwise it is, if it is the center of the Gaussian is at the origin, then the expectation value becomes 0. Now let us find the expectation value of x square for the same if the particle is demonstrated. So now here, by the definition, this is from minus infinity to plus infinity, psi star x square psi dx. You substitute for a psi star and psi here, so the integral becomes minus infinity to plus infinity x square e power minus alpha square x square dx. Now by using the we have already so we have the standard integral 0 to infinity x power 2n e power minus ax square dx. This is equal to, this is the standard value, standard integral, square root of pi 1 into 3 into 5 etc. up to 3n minus 1, and this is divided by 2 power n a power n plus 1. So if you remember this value, you can write down the result very quickly. So you remember some of the standard integrals. So this is your standard integral. Now you compare this one with this standard integral. If you put n is equal to 1, you will get this. And here the coefficient a and alpha square. So in that result, you replace a by alpha square and n by 1, then you will get this area. So this is a constant term, and the integral value is here root pi into 1 divided by 2 power 1, because n is 1, and this a is alpha square, and n is equal to 2, so 2 plus n is equal to 1, so 1 plus half, which is 3 by 2. So this is your the result. This is the integral value. So integral of minus infinity to plus infinity x square e power minus alpha square x square dx is equal to this value. Once if you simplify, you get 1 by 2 alpha square. So the expectation value of x square is equal to 1 by 2 alpha square. Now suppose, let us here you take psi is equal to a e power minus half alpha square x square. This can be written like this: a e power minus x square, and this part can be expressed in the denominator for this function x square divided by this one. So this is a denominator part, and again this can be expressed by a e power minus x minus 0 whole square divided by 2 by alpha square. So once we do this one, this is a denominator part and this is the center. The center is 0, the origin. So the expectation value of x square is found to be the denominator divided by 4 plus the center whole square. So this is using this you can evaluate this expectation value x square very easy without doing any solving. You can directly substitute from the over function. You can obtain the result very quickly. So in the competitive examination, time is also important. So if you use this idea, you write down you express the over function in terms of this form. You find the center, you find the denominator. If both are known, then the expectation value of x square is equal to denominator by 4. The denominator is 2 by alpha square, 2 by alpha square divided by 4 plus origin square. Origin is 0. Here, center is 0. So center is 0, 0 whole square is 0. So this is 1 by 2 alpha square. So without evaluating the integral, you can easily obtain the result. Suppose if we take one more example. If psi is equal to a e power minus 2 by sigma square into x minus x naught square. Now this can be expressed by a here. What is the expectation value of x square? This is using this idea. Denominator by 4. What is the denominator of this function? X minus x naught square divided by sigma square by 2 is the denominator. So sigma square by 2 is the denominator. So denominator is sigma square by 2 divided by 4 plus here what is the center? X naught is the center. Here the center is 0. The origin is the center. Here x naught is the center. So the center square is x naught square. So this is your result. Sigma square by 8 plus x naught square. So if you remember this one, then you can write down the result very quickly. So because since time is more important, if you remember this type of ideas, then you can write down the result very quickly. Then let us consider one more example, one more question. Find the ratio of expectation value of R divided by R suffix P of an electron in the ground state of hydrogen atom, where Rp is called as the most probable value. The most probable value, the probability density will be maximum. So for the ground state, psi 1s is equal to 1 divided by square root of pi n r cube e power r by n r, and the probability density here the radial probability density, so the psi star psi r square square radial density. So this must be maximum. If it is maximum means if you differentiate with respect to r, it must be 0. For maximum, if you differentiate with respect to r, it will be 0. So you differentiate d by dr of psi star psi r square, and this must be 0. So psi, you know psi and you know psi star r square, and if you differentiate and make the 0, and solving this, the r will be the most probable distance. So Rp, we can find that this value is equal to nr, and the expectation value of R for the hydrogen atom of this in the ground state is already calculated as 3 by 2 nr, because we have already calculated 3 by 2 nr. So if you remember, you can do this, otherwise you have to do this problem again. So 3 by 2 nr divided by Rp is nr, so this is 3 by 2. So this ratio is equal to 3 by 2. So in this option, 1, 3 by 2, 2, 5 by 2, this option is the correct option. So this was one of the questions asked in your previous net examinations. Now we will discuss the other important problems in the next class.